We are now ready for problem 32. This involves vectors once again, but we talked about this thing called the dot product. And here's an equation that uses the dot product. If you have two vectors, vectors A and B, this equation says the cosine of theta, theta is the angle between these two vectors, equals A dot product B, that's what this represents, this is dot product, over the magnitude of A times the magnitude of B. So in problem 32, in this case they have vector V, which is I minus J, so it's 1I minus 1J, and vector W, which is negative I plus J. And they first say, what is the dot product? Remember the dot product, you simply take the I parts and you multiply them, 1 times minus 1. Then you add it to, multiply the J parts, minus 1 times 1. Looks like the dot product is negative 2. That's the first part. Then they say find the angle between these two vectors. So cosine of the angle is, well, on the top is the dot product, which we already calculated. Now on the bottom is the magnitude of the first vector. So magnitude, right, you take the I part, the coefficient, you square it, and then you take the magnitude or the coefficient of the J part, you square it. Looks like it's 1 plus 1, square root of 2. Do the same thing for W. Take minus 1 and you square it, and you add it to 1 squared, square root of 2. So we have a square root of 2 times square root of 2. It's like negative 1. So now we ask ourselves, what angle theta do you take the cosine to get negative 1? This is like a unit circle problem. We're on the unit circle. One angle on unit circle is the cosine negative 1. Right here, right? What is that in degrees? 180 degrees. So if you got, we can actually draw these vectors. I minus J, so one I and minus 1J, negative I, positive J. So here's vector V. Here's vector W. What is this angle? Obviously it's 180. And now they say, are these vectors parallel or orthogonal or neither? Parallel means they run same direction or same, they may be opposite directions but the same angle. Put it that way, the same angle. Orthogonal means they go at 90 degrees, or neither is something different. So parallel means either 0 degrees or 180 degrees. Orthogonal is 90. And of course, obviously, ours are parallel. So the answer to this last part is that our vectors are parallel. I think we do a second problem. Actually, a couple more. So 33. Same thing. They give us two vectors. V is the 3i plus 2j. W is 2i minus 3j. And first, they ask for the dot product. So you take the x parts and multiply them. 6, add it 2. Multiply the y parts, minus 6. Looks like the dot product is 0. And now they want the angle between. So the equation is cosine of that angle is the dot product over, multiply the magnitudes. This is real simple because I know the dot product is 0. I don't even have to take the time to calculate those magnitudes because 0 or anything is 0. So I'm going to have cosine of theta equals 0. Now you ask what angle, theta, is the cosine 0? How about 90 degrees? So if two vectors are 90 degrees apart, what are they? They're orthogonal. Looks like there's one more of these, 34. So give you guys lots of practice. So this one, vector v is square root of 3i minus j, and vector w is I plus j. Same thing. First thing to do is what's the dot product? Multiply the x parts, square root of 3 times 1, add it to multiply the I parts, minus 1 times 1. That's a little ugly. It's like the dot product is square root of 3 minus 1. So what's the angle? So you take your dot product. Now, magnitude of v, square root of 3 squared, which is 3, plus negative 1 squared. It's like it's 2. Magnitude of w is 1 squared plus 1 squared, square root of 2. Now this is where you actually need to grab your calculator and see what this number is. This is pretty messy. So let's do 3 square root minus 1 divided by 2 divided by square root of 2, 0.2588. Of course, theta would be the inverse cosine of this. which is 75 degrees. And now that's the question. Therefore, if these two angles are 75 degrees apart, are they parallel? No. Orthogonal? No. They're neither. All right, now the last few questions all deal with parabolas, ellipses, and hyperbolas. So let me go and stop this video, though it's not that long, and we'll pick up fresh on the next one.